So this question is coming from May June 2023, paper 3 variant 2, and this is the fourth question. We are trying to solve the equation that is having a relationship of cos x with the cos of x in the domain 0 to 2 pi. So whenever we are given an equation to solve and that involves trigonometry terms, and if you notice, the angles are different. Okay, cos x is there and then cos of half x is there. So in this kind of cases, it is always recommended that you either convert your cos x into the cos of x format or the cos of x into the cos x format, so that you are having your entire equation either in the form of cos x or the cos of x. And after that, it just becomes your AS level concepts that how you solve it after that. So what is the formula that connects your cos x with the cos of x? Is there any formula that you've learned? There is no straight away formula. Even if you look into the MF19 booklet, you will not be able to find such formula. So it means that you need to derive this relationship by yourself. And now if you look into your last pointer that I have talked about in the key pointers of P3 trigonometry, you should be aware about the manipulations using the double angle formula to simplify or convert a given format into a specific format. So because I am dealing with the cos, there are two cos terms. The double angle formula that comes to my mind is the cos 2x formula. So if I'm writing cos of 2x, and cos 2x is three different formulas, I'll be using the cos x version, that is 2 cos square x minus 1. Now I need to use this formula and do the manipulation so that I can get a relationship between the cos x and the cos of x. And the magic it's going to do over here is simply by understanding that if you divide the angle by 2 in the entire equation, the relationship that you will be getting is this: cos of x is equal to 2 cos square of half x minus 1. So this is the relationship that you are able to develop. And now finally you are having a connection between cos x and the cos of x. Now you can simply take out the entire formula, put this entire formula in place of the cos x over here. You will have a quadratic in terms of cos of half x. And you know from your AS level how to solve it from there. So yeah, let's go ahead and solve this question very quickly. So to start with, I'll simply use 2 times. In place of cos, I'm putting the entire formula that I've derived over here. That is 2 cos square half x minus 1, then minus cos of half x is equal to 1. Now from here, if I simplify it further, I'll be getting 4 cos square half x. And after this, I'm going to get minus cos half x. From here, the constant is going to become minus 2. And then if I bring the 1 on the left side, it will become minus 2 minus 1, which is 3, which is minus 3 actually. Now you can see there is a hidden quadratic in terms of cos half x. So what you can do is over here, you can directly say that let u is equal to cos half x and solve the quadratic equation. 4u square minus u minus 3 is equal to 0. Or you can go ahead with whatever approaches that you've learned in your AS level. Okay, but this is something that is very useful for a lot of students, so I'll stick with this. So I'll go to mode 5 3 4 minus 1 and minus 3. The value of the u that I'm going to get is 1 and minus 3 by 4. And from here I can make factors u minus 1 and 4u plus 3 is equal to 0. Now I know that u is equal to cos half x. So this implies cos of half x is equals to 1, or cos of half x is equals to minus 3 by 4. I'll cross check opening my calculator that the values of minus 3 by 4 and 1 is correct. Yeah, they are correct. So now I'm going to use ASTC diagram to solve this. So whenever you are given multiple angles, you know that you can, of course, this is again coming from your AS level concepts. I'm not explaining that. What you can do is you can just say that alpha is equals to half x, alpha is equal to half x. So from here you will get what? You will get cos of alpha is equal to 1, but now you also need to change the domain. So what is the domain? Domain is going to be half of x. So 0 to pi. So I'm trying to solve this in between 0 to pi. Yeah. And this also I'll try to solve in between 0 to pi. Cos alpha is equals to minus 3 by 4 in between 0 to pi. Because of course we are dealing with half of x, not the full x. Now what am I going to do? Whenever I'm having cos alpha of 1, I can use the graph. What is the graph over here? Let me draw quickly. Again, it's up to you guys how you want to solve it, because after this process, it is all AS level concept. After this process, or I should say only this process, everything else you're doing is just your AS level stuff. So cos x graph is going to look like this in between 0 to pi. And in between 0 to pi, it is having a value of 1 only when the alpha value is 0. So from here, you can say that your alpha is equal to 0 is one solution. And from here, I'll be using ASTC diagram because I am comfortable with the ASTC diagram for every cases apart from 0, 1 or minus 1. In that case, I always draw a graph like what you can see over here. But anyways, I want cos alpha to be negative. Cos alpha is negative in the second and the third quadrant. And because my domain only lies in between 0 to pi, I will have no solution over here. So the only solution I'll be getting is what? I'll be getting this alpha over here. So that is going to be alpha is equals to pi minus cos inverse of positive 3 by 4, because this angle itself is cos inverse of positive 3 by 4. So I'm doing entire pi and then removing this much angle to get this much part. So I am having two values of alpha, 0 and pi minus cos inverse of 3 by 4. How do you get x values now? Just substitute your uh, this relationship over here. In place of alpha, write half x. So your half x is equal to 0 comma pi minus cos inverse of 3 by 4. Just multiply both the angles with 2. 0 into 2 is 0 degrees. And this will become what? Let me open the calci. Just make sure that you are in the radians mode, shift mode 4. So 2 times pi minus cos inverse of 3 by 4. And the answer over here, correct to 3SF, will be 4.84. Of course, this is not degrees, this is radians. So I'll just remove that degree symbol. And this becomes your final answer. And it is always a good thing to go ahead and cross check it. Now the thing is, how do you cross check? Always remember in the trigonometric question to cross check your answers. So you can substitute your 0 and 4.84 directly into this equation and see if it's coming approximately equal to 1. It won't be exactly 1 because of course you are taking the round of values. But yeah, at the end you should get 1. So what I'll do is, I know my answer is, the full answer is over here like this. I'll store it in my calc in the answer variable. It is stored. I'll put 2 cos that value minus cos of half of that value. Now if I press the equal to button, it should come out to be 1 if it is correct. So 100% we got 1, so it is correct. Now you can also do it by putting your x value as 0. So 2 times cos of 0 minus cos of 0 into half is 0 only, so cos of 0. Even this should come out as 1. Indeed, this is coming out as 1. So this guarantees that whatever answers that you have found over here are correct. Okay, maybe you are missing out on some solution. That could be the case if you are not using your ASTC diagram properly or the trigonometric rules properly. But whatever answers that you got, you are cross checking it on the spot using your calculator.